All right, today we're going to be doing lab 11D, and the purpose of today's lab is to verify that if you actually have 1 mole of a gas at STP, that it really occupies a volume of 22.4 liters. So we're going to run a reaction where we make our own gas as a product of this reaction. We're going to collect it in our water trap, and we're going to calculate its volume and find out if it really is 22.4 liters at STP. So let's get to it. All right, here we go. So let's take a look at our materials. And it says that the first thing that we will need is a digital balance, which is just another fancy word for a scale. A 10 milliliter graduated cylinder, a 150 milliliter beaker, some 3 molar HCl, which is very dangerous. Some distilled water, which we have filled our 150 milliliter beaker with. A sample of magnesium metal. 1 water trap with a 50 milliliter eudiometer. A size 00 rubber stopper with a hole in it. And last but not least, a piece of string. All right, let's do it. All right, the first step says to record the barometric pressure of the room as supplied by Mr. O. Now it says to record the mass of your magnesium sample to the nearest 1/1000th of a gram. Now it says to tie your string around your magnesium sample. I'm going to do this by folding the magnesium into a little V shape, and then I'm going to tie the string into a loop just so it makes it easier to get the magnesium around it, because it's pretty small. Now it says to measure out 10 milliliters of 3 molar hydrochloric acid and pour that into the eudiometer. So here we go. Now it says to fill the eudiometer with distilled water all the way to the top, but it advises that we hold the eudiometer at an angle and pour the distilled water down the side, as that will prevent the hydrochloric acid that we already added from mixing with the distilled water until we're ready. Now it says to insert your magnesium metal into the eudiometer. Here's why we tied the string around it. If we put the magnesium into the eudiometer, it's just going to float on the top of wherever the liquid is. Well, we don't want that. We want it to stay near the bottom. We want it to stay near the opening. So what we're going to do is we're going to loop the string over the side, and then we're going to insert our size 00 rubber stopper, which is just the perfect size. And that's going to hold the string and the magnesium metal near the opened end of the eudiometer, which is what we want. So here's what that looks like. Now we're actually ready to start the reaction. So here's what we're going to do. We're going to invert the entire eudiometer. Remember, the hydrochloric acid is at the bottom. When we flip it over, the hydrochloric acid is going to be at the top, and it's going to fall towards the new bottom, which is where the magnesium is. Remember that the magnesium is going to stay near the bottom because it's attached to the string. When the hydrochloric acid falls through the distilled water, which it will because it's a solution and it's less dense, it'll contact the magnesium. The reaction begins. We're going to form hydrogen gas, which will collect at the top. By the way, the hole in the rubber stopper is to let the water out as the reaction takes place, so we don't blow the rubber stopper out and ruin the entire reaction. So here we go. That's our acid falling through the distilled water. As it reaches the bottom, we see the reaction start, the magnesium reacting with the hydrochloric acid to form hydrogen gas, and there go the bubbles. Let's watch. Now the reaction actually went a little too far because the piece of magnesium that we used was a little big. But if we start over, we have to measure everything and weigh everything all over again, and we don't need to do that because we can get creative. What I did is I simply made a little extension for our eudiometer. And looking at where the meniscus is, I'm going to call that 52.3 milliliters. All right, the last thing we want to do is record the temperature of the water in the trap so we can find the vapor pressure, because we're going to need to use Dalton's law to get the partial pressure of the hydrogen gas we just collected. So here we go. All right, you have all the data. Now you can find out if 1 mole of any gas at STP really does occupy 22.4 liters. So good luck.